I think
Yes.
we can look at Saudi Arabia or some developing countries in the Middle East that they created new technologies for water
Yes.
recyclings and how they want to create artificial lake, artificial
Mm.
river, artificial uh, lands that they change the weather, they change the climate the, for the regions, and it's very nice.
Yes. Yes. I think I totally agree. Yeah. Yeah. Okay. Let me just carry on and finish my presentation. So, I mean, I wanted to just highlight the importance of the water recycling. And if you just look at that, we have like a dynamic simulation of water resources. There are like some steps we need to just follow, and we can just use using MATLAB, for example, this sort of that. So I'm just going to try to pass quickly. And also at the same time, we can optimize water recycling strategies. I know there are some like the steps we have to just follow: vectorization, pre-allocation, model refining, dynamic adjustment, and parallelizations using the GPU things to just speed up the process of like the optimizing process. And Dr. Amir is like the expert in that kind of like the optimization techniques here. So, and other like the things, climate sensitive modeling, we can just like include the sensitivity of the climate variabilities to just do the sensitivity analysis and analyze the system under uncertainty. Another like the point is like the historic approach for water recycling. We have to just look at the comprehensive approach and try to just include all the components and elements together. So that's like the nice figures that we have. And also for predictive model, we can use either deterministic and probabilistic models to just look at the water demand predictions. So that's another like the aspect. And also data-driven models, we can also use if you have like a sensor-based data, we can just like collect the data by using some typical SCADA system and try to just like develop some data-driven, like for example, AI-based models for predicting the system and analyzing and operating in real-time performance. And also another aspect is life cycle assessment, or LCA. LCA is a very typical. We have to just include any kind of like emissions, could be like the H2S, CH4, or any kind of like emission specifically from the wastewater treatment, and try to just include all of them and analyze them through the life cycle assessment. So you can see how we can just like look at from life cycle assessment, consider anything from construction, operation, and demolition all together. And in this way, we can just consider different components of the system and see which one can just lead more to carbon footprint, energy footprint, or water footprint. And then we can just make a decision, different kind of like options, which one is better. And finally, we can also like look at integrating IoT and AI. So you can see here, if nowadays, I think it might be good to just like seriously look at that, how we can just like integrate anything with like a Python, based programming in ChatGPT or, GitHub Copilot that is also like connected and develop some sort of like AI based and IoT. Specifically nowadays, we have lots of sensors nowadays collecting real-time online data, or we can easily like set up and install some sort of like AI-based system. I think this is the most important like the area that we should focus. If we want to just focus for any real project, for any projects between the countries, Europe, UK, and North America, we have to just invest a lot for research articles, everything. We have to just focus on that. IoT, how we can just set up some IoT technologies. I think this is like a really, we are lacking in that area. Normally, the approach that we found is that we have to use off-the-shelf technologies. So we are not at the stage to just develop some sensors. We have to see what sensors are available in the market. Let's say humidity, water level, or whatever sensors, and try to just, off the shelf in whatever is available, like quite cheap, more or less. Try to just connect them in some sort of like a compartment, a package box we can design, and see how we can just assemble such a the IoT system. And let's say install it in like a river. Let's say install it in like the wastewater system, in a way that the information can be collected in a real time and submitted to the data center. So one of the things that we just wanted to just see, this is connected to the contaminations as well. Apart from the water quantity for contaminations, as Mohammed knows better, we, for some kind of like detecting some contaminations, we have to take the samples to the lab. Water quality samples can be just analyzed by using the water quality, like the chemicals analysis. Water, some of the organic contamination has to just go with some very intensive test and very expensive like the machines. It's called like the LC mass or GC mass, which is quite expensive, but it can detect lots of like the microbial, for example, pharmaceutical contamination. They are like a completely emergent contamination. Microbial looks like, for example, any kind of like the viruses, COVID or any other things. It has to go with that kind of like a lab test. One thing that we can just do is to try to just find some sensor-based system and try to just find some sort of like a correlation by using finding a correlation between the lab test result and also like the IoT-based sensors. I mean, if you have like a collected data for like a couple of years and we continuously for like a year or two or like even shorter, we can test them in the lab, okay, and just do the collected data online with the either like the sensor that we set up and install, or any kind of like the ground source stations, or even like the satellite, satellite that we just can have SAR data and other like the optical ones. And if you can just find some correlation, so we can just like to develop some sort of like the predictive models, predicted by using the AI again. So in a way that we don't need to just go with the intensive lab test. So by using the sensors, we can say, for example, oh, there's the contamination has already been detected, or there's a sign of like contamination is going to be here, and that has to be carefully looked at. So I think this is like something we just gonna work on some projects and proposals. We were not successful for some of them, but we are working on that to just have like a proof of concept. And I think Mohammed is like more or less aware of some of them. But I think this is like something that's good to just work on that. But we need to just have like some sort of like a proof of concept as well. In a way, if we want to just apply for like a large fund, we have to just make sure we have a good a proof of concept to convince the reviewers for that. Yeah, that is more or less for my presentation. So if you have any, please feel free, especially in that field, if you have any comments or suggestions, please go ahead.
Okay, Professor Gurush, thank you so much for your presentation and some given information about this field of research. And again, I should say thanks for your efforts also in EIL, because now we are waiting to receive the Scopus near in the next year. We don't know, maybe by chance. Yeah, hopefully. And now, with guys, after this meeting, we will be in touch, and we will start to collaborate. Also, some collaborators in mentioned before to you in, for example, Europe, in America, because of the diversity. Will create the network by three guys that they contributed in this workshop. And also, first, I think if I will ask Alireza and Zabiola and Ruhollah, if you have any comments or question, or please let us know.
Maybe I can come to the first presentation slide. Yes, go ahead, Alireza. Yes. I don't think so. I don't think that. Yeah, yeah, yeah. Are you familiar with the LCMAS, Alireza? Yeah, yeah. I think that that is the only way, as far as I know, for detecting these kind of like the particles contaminations. But I mean, the point was that when we have the, I mean, the idea behind that was that once we have the contaminations, let's say, for example, a source of contamination for industrial, I think the main concern that we're just going to focus, or like the residential. In the UK, and I think more or less in Canada as well, Amir knows better, we might have a combined sewer. I mean, in the UK, we have, it's a very popular combined sewer. Combined sewer is the sewers that sanitary sewage and surface runoff collected in the same pipe. So the problem was that at the time of the heavy rainfall, because the pipeline has a specific capacity, if the load, like the surface runoff, draining to the this kind of like the pipeline exceed the capacity, it definitely has to spill over, and spill and overflow into the like the receiving water bodies. Let's say to the like the rivers, and that causes like a contamination pollution, and that's the where water environment agency or any kind of like the monitoring bodies, they're just going to find water companies because of like the careless operation, or something inevitably might happen. But and the solution for that, we need to just have like early detection or early warning. For example, once you're just going to see, let's say, for example, if you're just going to if the water company knows like tomorrow there is a heavy rainfall, and probably is highly likely that the overflow is going to happen, so they can just do something. So that's like the idea. But the thing is that the question is that, okay, how we can just spot or detect this kind of like a contamination, organic one, like the PFAS or other things that is like a quite very small. So the only this is what we suggested, and we just trying to just secure some funds and other things as well, is to try to use the lab works, or this incentive lab work, because the LCMAS, you said like there's quite a few only in Iran, and here, like I can say in the UK, is quite like expensive. It's like a 200,000 or more than 100,000. So it's not like something easy, and it's like a test can be quite intensive and time consuming. It's not like something easy you can just do it in a few minutes. So for that reason, it's better to just like find other parameters that can be detected by sensors, and at the same time we can test that water sample and then find a correlation, in the AI and other like the tools that we're just gonna have. And then later on, we're just gonna say, rather than like taking the time-consuming samples or test like with LCMAS, it's like time-consuming and expensive test. Why not? We're just gonna use the sensors to at least detect the hazardous and potential hazardous area. I think that's the idea that we have behind. So, but first of all, we are trying to just like take some samples in London, trying to just like use from the River Thames, the main river in London, and try to test it in like in the lab in UCL, and they have like several like the LCMAS, and one of my PhD students, Babak, Mohammed knows him.
Yeah.
He's trying to just do that one and see, and then later we're just gonna see any kind of like a correlation between them. But the what sensors and what parameters can be used for early warning and detecting these kind of things. To be honest, we have to just see which one. We have some sensors to detecting the total suspended solid, TSS. or TDS as well. I don't know.
Yeah.
Do you have for sensor for TDS as well or no?
Yeah, it is difference between total solid. It's approximate method.
Yeah.
Total solid and suspended one.
Yeah, so if you have such a sensors and if you find some correlation and also important thing is that depends on the type of contamination. Let's say there's a lot of wastewater, domestic wastewater, industrial wastewater. They might have a different levels. If we need to just first of all identify the source of the contamination, is it like it comes from the domestic, comes from like industrial? For example, a factory discharge, and then test it in the lab and get the samples and then try to just analyze and find some sort of like if you can just get something like that, I believe this like a very like a novel kind of like the proof of concept, but we can just do it in like a lab works like a shorter scale, and then later we're just gonna see. I mean, theoretically there shouldn't be any correlation, but anyway, so we're just gonna do our best to see how we can just get that one.
Also, Professor, may I add something to your description? Just I wanted to say that, for example, for microplastics, yes, also there are some technology that, because microplastic, there are lots of bonds and chemical bonds in their structure, and they are detectable. But about the PFAS, exactly as you mentioned, based on the mass detector and also some technologies such as HPLC, it's measurable. But I should say that measuring, a real-time measurement of PFAS group, all of them, PFOA, PFOS, GenX, and different groups, it's really boundary of science. And who can, because it's very expensive and time consuming, and in this condition, if someone can create some complexes or some methods for real time based on laser, based on optical system, and etc., and find the exact mechanism, because they are very there are lots of steadiness in this system, and because of the detecting them is very complicated, as you mentioned before.
Yeah, I truly agree with you. Real-time optimization is a very novel concept that can be used for optimizing and analyzing water supply and wastewater collection systems. And I think this is an area of research that can be explored more when we have advanced use of machine learning and optimization algorithms that can be help us to heuristically optimize the data in time for analyzing the solutions based on the conditions and the complexities that we encounter for our water supply and wastewater collection system, right?
Yes, specifically once we just kind of do it like in a real-time error detection, we need some mainly like the predictive models like the AI based, which is going to be quite fast. And also if you want to just like to do some optimization, it has to just like to do it quickly as well. I mean, in a short time we can get that one. But predictive model is really, really important to just like to do it very quick and also like the efficient. I mean, efficient like with a good level of the accuracy, because prediction with a low accuracy is absolutely nothing. So we have to have like a good estimate. Otherwise, no one can rely and trust on those data.
Yeah, exactly.
Yeah,
exactly. Yeah, that is why the AI is very novel and very can be explored more in the academics for water simulation, water recycling, and this research area is always can be explored, can be published by many ideas for especially for the water crisis and water shortage in Asia and the Middle East that we have. We need to use these techniques.
And I think nowadays, because of like the new AI revolution that's happened
Exactly.
since last year. I mean, with the appearance of the ChatGPT, I think we have to just maximize our potentials of using that one. Otherwise, I think in the near future, everything is going to be like covered by this kind of like the generative AI. And the thing is that the fact is that we have to just effectively use this kind of like a generative AI, like a ChatGPT or GitHub Copilot. Currently, the GitHub Copilot is trying to just do that kind of like a job for programmers or those scientists who are like closely working with programming. So I think because most of the people are currently using the ChatGPT as like the text revisions, for the text, especially I don't know in Iran they can just do it or not for the Persian, but we don't have Persian essay or writing. But in English, is very popular, and academically we have to take care of the students don't like to take advantage and unfairly use this kind of like the technology for writing the submissions. But nowadays it's going to be used a lot only for text. But I think from my point of view, now we as a scientists or researchers, we are really like to have to just be dedicated to this kind of like using the ChatGPT and Copilot, GitHub Copilot for writing our codes, because it can significantly speed up and accelerate programming in a very short time. So I think this is like something that we have to do to speed up our research and findings, hopefully.
Yeah, exactly. I truly agree, and I can see that. Both ChatGPT or GitHub Pilot are not very accurate, are not very expert for the exact codes that we need, but they can provide some draft code that can be used for our research.
Yeah, no, that's true. I mean, that's my suggestion as well. To like Mohammed might be like to have some other sessions as well. How we can just like speed up programming by using this specifically with the GitHub Copilot. Have you seen that kind of like things that it can just generate coding very quickly? Amir?
Yeah. From my side, I think you are asked from Mohammed. Yeah. I personally used GitHub that they have some drafts that can be customized for your programming tools, for example. Nowadays, if you want to ask ChatGPT to write sample codes, it gives you the main idea. What would be the structure of the code, and what would we do at each step. The details depend on you, and depends on your specific constraints that you want to meet. But we can use ChatGPT and GitHub for speed up the process of codings. And nowadays, the writing the codes is not very difficult if you are familiar with ChatGPT and GitHub. That gives you the base idea.
I mean, I'll just use it like several times. Even you can just scrutinize and challenge ChatGPT, and every time, maybe 10 times, 20 times, and it can just improve and revise the code every step. And you can challenge and keep if you just gonna like to ask and debug the code, everything. And it can just like to go with as well as the basic and draft one. If you're not happy with whatever is expected, you can just straight away ask to just revise it. But I think one thing important is that whoever like the developers the code has to just carefully look at that what is generated by that, because it's like a machine and it has to be monitored by someone to just go ahead with that. Yeah. Okay. So yeah. I think I hope you enjoyed this presentation, but I've tried to just like make it more interactive, not like go into the text stuff to just avoid any kind of like the boring presentation.
No, thank you so much. It was very fascinating, also specifically for me. And I should say that in this meeting, we have another audience, Mr. Mohammed Shuaib. Can you introduce yourself?
Mohammed, yes.
Assalamu alaikum.
Assalamu alaikum.
Alaikum. Salam alaikum.
Hi, Muhammad. Salam.
Hopefully, sir, I hope you all will be fine and doing good in your life by the grace of Almighty Allah. Sir, I'm
Thank you.
Muhammad Shoaib. Currently, I'm at semester civil engineering student at University of Engineering and Technology, Peshawar, Pakistan.
Mhm.
And I just joined this meeting so that I can learn something new about water resource side. I'm interested in it, and I studied few courses relevant to water resources. And currently, we are studying irrigation, and we study hydrology and hydraulics, floods, these subjects.
Okay.
Well,
Okay, thank you for your introduction. Just I should mention again because you started this meeting a bit late, but we will share the PowerPoints with you. But we will have two other lecture after Professor Kurosh. But also we will share the video with you and other guys. But if you agree, everyone, for take a rest just for 10 minutes, we will have one break, and then we will have the presentation of Dr. Amir.
Yeah, I'm ready. That I can. When you are ready, I can start. Or we can take a break. I'm okay. It's okay. Yeah.
Okay. Okay. Thank you so much. If you agree, because between each presentation, 10 minutes, we will have the break, and if you agree after 10 minutes, we will be at your service.
Okay, I will back after 10 minutes. Thank you so much.
Okay.
thank you. Thank you.
Thank you. Thank
Excuse
you.
me, sir, one question.
Pardon?
Sure.
So now in Pakistan now it's Tarawih time. It's Ramadan. It's Tarawih time. Will it the recording will be shared with us so that I can watch it later?
Yeah. We will. But if you can be in the presentation, is better. But if you cannot, yes, we will
I
share
will
with
try
you.
to
But
reach, but now it's about I just 30 minutes.
okay, time of azan. Okay.
No, traveling. I think it's just.
Oh, traveling time. Okay.
Yeah,
Yeah, for traveling. Yeah, I see.
Okay.
Okay,
Okay.
but we're already available for the presentation, and we can talk about the topics that I want to introduce. Yeah, it's okay.
It's okay. Thank you. After
Thank you,
10
sir.
minutes, we will come back. Okay.
Sure. Thank you.
Okay. Thank you.
Yeah. Okay, and let me entire screen. So, can you see my screen?
Yeah.
Okay.
Yes.
So, if you are okay, I want to start.
Yeah.
Yeah. In this short presentation, we'll talk about the use of simulation and modeling approach for water recycling, and we have also focused on the Nordic countries, also the Middle East countries for our presentation. In the following, I first provide an introduction about our concept, then we talk about the application of machine learning, and then deep learning methods, the artificial intelligence driven optimization using operation research, reinforcement learning, and finally development of a decision support system for our application using these techniques. And I also added a case, a research article that how we analyze and optimize an integrated water supply and wastewater collection network in reality. So, having an introduction, we should say that we have many challenges in water management, as we previously talked with Professor Kurosh. And to address these challenges, we need to provide efficient solutions that we can reduce the costs, we can improve the adaptability, and also reliability and efficiency of the water systems. And in this regard, machine learning, deep learning, reinforcement learning, operation research, and optimization tools can help us to define these solutions. And these solutions can be customized for different applications, like in agriculture, industry, urbanizations, and many other applications that we have customers and we have polluters. The main challenge would be how we can predict or estimate the demands of the customers, because the demands is always a challenge in water management. How we can reduce the pollution for the period of the water recycling and water management. And we also should mention that the crisis and the water shortage is a very challengeable, and the main reason that we use optimization techniques, machine learning techniques, and generally AI solutions is to improve the efficiency and to help our distribution and conservation water system to be efficient and sustainable. And in this regard, we need to use and integrate different artificial intelligence, deep learning, machine learning methods for monitor, for control, and simulate our water systems and wastewater collection systems. As you can see from this figure, it shows that this water cycle that how the surface water is distributed, and it from the sea and to the mountain, and how we can use it in different sectors such as the agriculture, industry, and customers. And we use of the AI, we want to address the challenges and providing insights for water management, for water network solutions. And there is to manage the systems, we need to consider the water supply and wastewater collection. It is important how we supply the water from the surface and how we collect, to recycle, to improve, to make, to develop, and to use energy using the wastewater collection. And developing such networks for integrating water supply and wastewater collection have different complexities and difficulties and risks that we need to consider. Many sustainable issues, the ecological patterns, and also the considering a full solution for all the flexibility, resiliency, sustainability for the water supply and wastewater management. And in this regard, we need use artificial intelligence mechanism for coordinating and integrating the water supply and wastewater solution. One of them is using the machine learning.
Dr. Amir, excuse me, I have a question here about myself. About some provided algorithm in MetaHeuristic. It is not related to this scope that you are presenting here. I wanted to, may I ask you please, say after that, if you agree in each appropriate section of your presentation, just it is interesting for myself that, for example, you develop lots of algorithm by yourself, such as Red Deer and SEO and some different algorithm. It's very interesting for me that how we can use that algorithm for as a closed loop supply chain or supply chain. If you want to see to the water ecosystem in between different resources and different demands, what's the
Exactly.
connection between them, and what uh,
Yeah.
which
Yeah.
gap can be filled by the application of the algorithm?
Sure. In the following, I will have this plan to
Okay.
define the water supply chain as a closed loop supply chain.
Okay.
That how we can provide a network to integrate these issues, and we'll talk about this issue. Sure,
Okay.
certainly about the closed loop supply chain, and then after that we have an optimization problem. We can focus on how we can use the materialistic algorithm or heuristic algorithms for optimizing. Such methods can be customized to any optimization problem, but for this type of problem, such as the water networks, because it has the two. From the baseline of network design, the water networks has more constraints that the typical network design, because we need to consider logistical issues, and also the pipeline. I will talk about them in more details, but I want to highlight that machine learning is nowadays very popular for analyzing the water recycling. We need to define the flowchart of the steps that we want to use for water recycling, for analyzing the parameters, how we want to predict the demand, and how we want to train our historical data.
Yeah.
In this regard, we have different machine learning methods, such as artificial neural system or AMPHIS method, random tree, forest tree, or many other machine learning models that can be used for our systems. Therefore, having many options for machine learning, we can consider different neural network or the short-term memory algorithm methods that can be used to improve the accuracy for water prediction demands and improving analyzing the water management systems.
Okay.
So
thank you.
machine learning is one idea. Another one would be contributing to the deep learning method. Generally in deep learning, we should consider the many layer for to improve and to train our data. When we increase the layer, for example, using the multiplier perceptron, we can consider that at each period, at each iteration of our algorithm, we can improve the accuracy to detect the errors or detect the data that can be important for monitoring the water systems, for analyzing the details for a multi-factor, multi-agent, multi-level water supply and wastewater collection system, and how these methods can be used. So, similar to the machine learning, in deep learning, we also need to consider different layer for analyzing and managing for our water supply and wastewater collection systems. Another methods that are very popular using AI data-driven optimization. The first step that we need to use our train data to start the optimization. In optimization, we need to first define the inputs, including the parameters, and define the decision variables, and to make an optimization models that the aim is to improve, that the aim is to use the predicted data from the learning steps using deep learning or machine learning that we got the input information for their demands or other steps, and then we use these data for improving our solution for decision making and to define the solution. As you can see from this for the action, that how we can get an optimal solution, that we need to analyze the problems and to provide a cycle that how we can integrate the train data with as the input parameters, and then how to can apply an optimization algorithm like genetic algorithm to find a solution for our water network, to design the pattern for our water network. Similarly, another popular technique that is very important, very can be used in our research articles, is the reinforcement learning. Is that this is very advanced machine learning method that can help us to learn the optimal actions and to reduce the errors in our system. Therefore, another very important suggestions for interested readers that we can use the reinforcement learning to improve and to design the optimal actions for our water recycling system. For example, as you can see, this is for one of the papers, that how we provide a loop and provide a connection between the variables, and based on the reinforcement learning to connect and to consider the details for our water recycling system. And using reinforcement learning algorithms, we can drive to the real-time decision-making for water supply and wastewater collection, that based on the real-time data, we can use the reinforcement learning for optimizing and to make the optimal decisions for water supply and wastewater collection network. And generally, a decision support system is to integrate all the machine learning, all the details from the operation research in an integrated manner to how we can define a full solution to for analyzing the water supply and analyzing the wastewater treatment plants, and the solutions that can be considered using the multi-criteria decision-making methods. For example, there we have many multi-criteria methods like TOPSIS, like DMATL, or many other decision-making methods that can help us to how to sort the criteria, how to analyze their weights, to consider different sustainability issues or different ecological or many scientific scientific items that can be integrated into our decision support system. Therefore, methods that can be used for the water recycling, water analyzing systems. And in the final steps, I want to provide a research article that how we can model the
Dr.
water.
Amir, excuse me to disturbing you. Just I have a question about the previous issue. Just it is my personal question. Did you try to implement the system dynamic with combination of meta-heuristic algorithm as a solver? For example, for system dynamic, now we are using VenSim software for implement. VenSim, Arena, different. It's like a VenSim logic that you can see here. But to implement, meta-heuristic algorithm as a solver specifically in this software, is it possible or not? Because I know that equations in VenSim is very, very simple, and we cannot create very complex loops. Is it possible, or we should use pure programming environments such as Python, MATLAB, or other one?
The dynamic dynamic models, they are simulation, okay, and we can use both meta-heuristic or many other software models for analyzing. You should consider that at each step for our dynamic programming. The dynamic is very iteratively, that at each iteration for our dynamic for solving, analyzing the model, we can use a meta-heuristic algorithm for making the decisions, and then consider the feedbacks, and then back to another step for our dynamic programming model.
But is there possibility to connect the solver to VenSim?
Yes, it is possible.
Yes, it is possible.
It's possible that we can connect the VenSim to a meta-heuristic algorithm for making the decisions on time. That this is probably very useful to analyzing to analyzing the trained data based on the meta-heuristic solutions.
Okay, thank you.
It is a good idea to use this, and let me provide an example how we can look at the water supply and wastewater collection as a supply chain model. In addition, in this paper, I considered the water shortage in West Azerbaijan, Urmia Lake, as my case study, and you can see that this is as we predicted, the water shortage, and it's very dangerous for environmental issues overall. And here I considered a network for connecting each step of the water supply and wastewater collection. We can consider the dam that we can use the surface water and the groundwater resources that are available in our systems as a purifying to move them to purifying center for making the drinking water, and then the drinking water can be used in our urbanization centers for our demand customers, for the home users. And the most important step after these step is how to get the return water, how to use the wastewater, and how to collect them in a wastewater collection system. And in this regard, we can consider using the making create energy from the wastewater using slot water that we can use and can have gas generator for making energy, or we can recycle this wastewater to have it recycled water and then distribute these recycled waters to agricultural and industrial zones. And then we've used.
Dr. Amir, excuse me, what was the main cost function in this loop? Energy or multifunctional?
The main cost function is in this network that I consider in this paper is the cost for the many items, for the location, for allocation, for transition, for purchasing, for holding, for inventory, and for the shortage. Okay. That we must consider that if we not able to provide it, to satisfy the demands for our organization, for our customers, we must pay a penalty. We cannot. We must able to satisfy the demands, and that is the cost of our systems. In this regard, I have considered some simplified assumptions. Now, I should say that in any optimization problem, we first need to simplify our network, the previous network that we provide here, based on the simplified assumptions, to define our optimization model. Then it is in this model that we can consider that what are the costs that we want to consider, and what are the assumptions that we must have. For example, we consider that there is no connection between the same facility. It means that we need there is no network between the purifying centers in our network, or we need to consider that there is no link between the wastewater collection center, and each wastewater collection center would be act separately to as a in our water supply network. And another assumptions would be related to the parameters that are uncertain. And in this regard, to estimate the parameters, we must be able to use the machine learning or any other learning methods for prediction, to consider to define the demands for the agricultural, for the industrial sections, for our home users, that we need to define consider the scenario-based analysis. In this paper, we consider probabilistic scenarios for estimating and to improve the accuracy of our input parameters that can be used in our optimization problem. So the main objective is the total cost that can be considered for the fixed cost, transition cost, purchasing cost, holding cost, and the shortage cost. And we use as it can be seen, we've used the parameters and decision variables for defining this objective function in our optimization model.
Dr. Amir, that was one objective function in your.
This is a single objective.
Single one, yeah.
Yeah, it's a simplified and single objective that we only focus on economic issues, and the rest of the other issues would be considered as a constraints. Therefore, this is the single objective that how we compute the costs for each for all the facilities and for the transition between based on the network that we define for the water supply and wastewater collection. And we, based on this issue, we need to have consider the inventory constraints that we have. We need to consider that we have evaporation on the surface water. We need to consider there are many factors that can make an impact on the inventory status of the water at each facility, based on the climate issues, based on the evaporation, based on the rain from there are predictions that how many rainy days that we have and how much the water that can be added to our systems at each period of in our system. Here we have the inventory constraints, and as a network that we have multiple facilities, we need to connect them, and we need to have a network balance constraint that shows that there is a balance between the inputs and outputs at each node in this facility. That here are the network balance constraints that must be existed in any water supply and wastewater connection network. We will have capacity constraints that to shows that at each facility there is a limitation for the water capacity that can be operated at each facility, at each water treatment center, at the purifying center, at wastewater collection center. There is a limitation for the water operated at each facility. And we have, in a water supply and wastewater collection network, we need to define different pipelines and the canals that can be used to connect the facilities to each other. And these pipelines have also the capacity limitation. We need to consider that the capacity that is suitable for the connections for the pipelines in our network. And we also have location constraints. That it means that we cannot locate the purifying center in any location that we want, based on the limited potential locations that we previously identified based on our historical data. Then we need to select one of them or a few of them based on the limited budget that we have for our network to make the location decisions for our centers. And finally, decision variables that can be are binary and non-binary variables in our optimization model. As an optimization model, we considered a case study that based on the West Azerbaijan province in Iran, and the source of the dams that are existed, and based on the data that we predicted, we solved our model and considered the cost function based on the realistic, optimistic, and pessimistic scenarios. And the more details about this paper, I suggested that interested readers can read the paper and ask their questions from me. But the goal was only to provide an example that how we can model a water supply and wastewater collection network based on a real case study, and how we can analyze the solutions based on the available data. And to thank you for your time. And if you have any questions, let me know.
Dr. Mamir, thank you so much for your very nice presentation and especially about your paper that was very interesting for myself. Also, maybe I don't know if Professor Kurosh if Professor Kurosh agree, we can have a meeting with together for define a project about the Eurostar call because it is started also with connection of I don't know Professor with connection of TULTECH, UWL, University of Quebec, and also Dr. Sadr. Because in the Eurostar projects in Euroca, companies should lead the project as the main contributor. And Canada also it's very strange for me. Also, Canada, USA, and China, they are located in the Eurostar region, but they are out of Euro. But in the list, you can find the country's name, and maybe in the field of specifically, in my opinion, the application of artificial intelligence in holistic view in the project, we can divide it into different tasks. Some of them can be solved by machine learning, some of them meta heuristics, and etc. But in the Eureka, there are some different aspects that they are following. The main one is commercial aspect, based on my knowledge, but Professor Kurosh, you know better than me. But in my opinion, about creation of one dashboard for based on IoT and using artificial intelligence for better management of water resources, about the recycling, with focusing on recycling in the household applications, and maybe it can be interesting.
Sure. Yeah. We will able to talk about this issue later, and I'm really also interested. Yeah, actually, unfortunately, Canada is not very. It's not very does not pay attention to the water resources and water consumption. The main reason that is has a very low population. Also, it has also many water resources.
Yeah.
That more than half of the Earth. I think more than half of the Earth, Canada has water resources, and I'm really interested. And there are also many professors that in Montreal that are working in this research area, and we can collaborate with them. And this is a very good opportunity that we have defined a research project, research grants, and collaboration for publications. Yeah, thank you so much.
Also, it's interesting because until June we have time. Okay, after this meeting we can talk about it. Okay, everyone. Also, we have another audience here. Fayazullah. Can you hear me, Fayazullah? Can you introduce yourself to us?
Hello, sir. My name is Fayazullah.
Okay.
I'm a student of civil engineering at University of Engineering and Technology, Peshawar, Pakistan.
Okay.
Pursuing my BSc degree, and now final year student.
Okay.
Nice to meet you.
Thank
you. Very nice. Thank you.
Yeah, very nice to meet you, I guess.
Okay. Thank you. If you agree, we can start the last presentation, and I know that I will start it, and I will try to summarize different aspects of this presentation. Let me share my screen. Okay.
Yeah, great.
Okay, can you see my screen?
Yes, go ahead.
Okay. Again, thank you so much for everyone, but I'm trying to say some main points because I know that maybe the meeting was a bit long, and here I want to focus to different aspects of treatment. Professor Kurosh mentioned to holistic view and the main data-driven and machine learning application about water recycling in houses and in different application industries, agriculture, and etc. And Dr. Amir explained exactly about the application of artificial intelligence methods in some different sites. The main aspects of that was connected to prediction by machine learning methods, different machine learning with focusing of deep learning, and another one was optimization in the loops and supply chains by meta-heuristic algorithm that I know that it's his main expertise. But here, I would like to describe some technologies about water recycling in buildings. Okay. Here, first of all, I should mention that there are lots of technologies, but there are some criteria for judging about them. As environmental engineer, when we want to select one of them, we should consider some criteria such as investment costs, material costs, chemical costs during the operation. The civil engineers and designers mentioned that 60% of share in decision making about technologies are related to operation duration, because during the operation process we should spend lots of money continuously, and based on this fact we should mention to some current cost. Okay. Maybe, for example, I mentioned to this in this picture, you can see there are some different methods. Then one popular method is the application of membranes. There are different types of membranes based on the porous size. For example, microfiltration, ultrafiltration, nanofiltration, and reverse osmosis, which is famous in the name of RO, because each of them has a specific application. When you want to decontaminate the rainwater, you should have microfiltration. You don't need to select very, very small pore sizes in the porous media. Therefore, it should be cheaper than other technologies that you can see here in this picture, the left one. Therefore, based on the specific application, we should find, appropriate condition of this technology, membrane technology. In the membrane technologies, the main problem is related to the fouling, because after decontaminate by trapping the pollutions in the pore sizes, we will have fouling in the media. We should have backwash. In the backwash process, in the reverse side of membrane, we will have another releasing chemicals in the nature. Okay, therefore it is the disadvantage of this method, but the performance of this method is very higher than other method. Operation is very easy, but in the simple way, I can say that it is not very green method for decontamination. Another one is adsorption. Here in the right and bottom of this page, you can see here in the adsorption, it's very easy operation system. We can have lots of decontamination of different types of pollutions, such as ions, anions, cations, or even microorganisms, different types. We can decontaminate them, but what is the problem? Again, the surface of nanomaterials in the column that you can see here, or nanomaterials or micromaterials, or all different types of materials that we are using in the columns, they are saturated after some times. but it is another technology that we can use it. The best one from the environmental aspect that we can say that it is the it is the most green technology. It is the biological treatment, because microorganisms, like in nature, they are helping us to decompose the structure of pollutions and create the simple compounds in the effluent. But what is the problem? It is the microorganism. Microorganisms are like humans, and therefore their behavior are completely complex, and we cannot predict their behavior. And because of that, the process has lots of collapse during the operation. And the main cost of this system is related to operators, because the operators incomes are very high, and their salary is very high, because they should be very expert person. But totally, I said all of them because I wanted to say that in each method we have some advantages and disadvantages. But why I'm telling these notices about these technologies? Because with the application of simulation, we can reduce the cost of operation and design, both of them. In the following, I should say that, okay, very fast, I'm going to some applications and some example about these methods. One approach that we should think about it based on, you can check it after our meeting in Scopus and Web of Science, data centers, and you can find lots of papers about the membrane. I think in each minute, some papers are published in the field of membrane application for environmental pollution, air, soil, a bit soil, but air, water, and so on. I should mention that here, but the application of artificial intelligence or other, I cannot say just artificial intelligence, other maybe classical methods of optimization are research gap. We should mention that because they are process, and in the process, process engineers, they don't like a lot the simulation and modeling approach, and some person who that they are working on the simulation, they don't care to the aspects of experiments. Okay, here we would like to say that with some modeling, that with the audience that you are participating in this workshop. After workshop, we will be in touch with together by TULTECH organization, and these codes that I will present these codes to you for promotion, and we will have one WhatsApp or I don't know other platform for communicating together for promotion of these codes. It's initial codes that we provided before. For publication in EIL journal, and also you will collaborate with some other scientists. Okay, I wanted to say that here in this publication, in this optimization process, we should consider some different aspects. For example, here, water flux is very important. Why? Because based on different concentration of pollution, it is related to a membrane. In the membrane system, we should decrease the accumulated flux of pollutions in the surface of membrane. It's very important because the falling process happened on the surface, and we will be in trouble in the operation process because we should spend lots of time and costs and materials. Another one is membrane thickness. Membrane thickness is very crucial aspects because in the some aspects of cost in the membrane providing is related to its thickness, and now there is pressure difference because with increasing lots of pressure fluctuations during the operation, we will have some exploitation in this small exploitation, partial one, in the lots of partial exploitation in the surface of membrane. Okay, therefore I said all of that. I don't want to talk about technical aspects of this process, but it is about the optimization of based on some logical method, FSolve. Dr. Fatullah Ifer is expert in, also Professor Kurosh, but it is one classical method for optimizing multi-objective functions in the same process. Okay, another aspect that I want to talk about about the biological process. I should mention that, as I mentioned before, biological process complexity is connected to behavior of microorganisms. Because of this fact, we should consider some different criteria when we want to optimize this system. You can see here, we use some heat maps. Why heat maps? Because with the application of heat maps, we can compare different cells which are linked to various aspects of process. Because microorganism, if you have a specific microorganism for decontamination of chemical oxygen demand as index of organic material in wastewater, when your pH is decreasing, they are not working. When it is increasing, they are not working. When temperature is increasing and decreasing, they are not working. They are very, very sensitive phenomena and live ecosystem in the environment. Because of this subject, we need to real-time optimizer. As Professor Kurosh before declared, we have some AI-driven systems that we can use them for controlling. And Dr. Fatullah Ifer mentioned about the application of meta-heuristic algorithm for optimizing. Here, if you see, we need to optimize and implement data-driven, real-time data-driven system because we have lots of sensors in the reactors. And for example, in activated sludge reactor or more complex systems such as SPR, sequence batch reactor, or other reactors, we have lots of sensors for detecting pH, alkalinity, temperature, and other parameters. We should, make decision real time as operator in each reactor for finding the possible problem. Because if we have decreasing the pH, 2 hours later than now, we will have falling, we will have rising, or other problems in the wastewater treatment plant. Because with the application of meta-heuristic algorithm and optimizer and making decision about using, for example, here in the left and above, you can see one optimization about some features. The feature here was connected to the performance of system about decreasing chemical oxygen demand and biological oxygen demand in the reactor. But biological oxygen demand, that we cannot compare, we cannot compute it real time and sensing it real time based on one ratio by chemical oxygen demand we are detecting. And here you can see in the left and bottom, you can see we increase and enhance some indexes in this process. Okay, is it okay if you have any question? Just ask me about these 2 slides. Okay. About the next step, I should mention some applications about combination of different methods. What is the main problem in this situation of wastewater treatment plants and water treatment plants? You can imagine that with one in the water treatment plant or wastewater treatment plant, we cannot purify the water resources just with one system. At least we need 6, 7, 8 or more systems because we have primary treatment, secondary treatment, and advanced treatment. each treatment system has influenced another ones. And because of this issue that I mentioned, we should connect all of them as a one complete and comprehensive system also for this problem. Why I'm telling this fact? Because if you imagine that in the primary system, we are separating solid phase part of wastewater. In the, and others in the primary, we are doing this one. In the secondary process, we are decontaminating the organic matter, just organic materials. And in the last one, as advanced, for example, one of advanced method, we are decontaminating, for example, the microorganism. But solid phase and also organic one, and also just organic from solid and dissolved one, and also microorganism, all of them, they have different behavior, and connecting all of them in one dashboard needs to high potential computation system, and also logical platform, because all logics should be considered in different way for meeting the contamination criteria. If you have any comments or question during my presentation, just come and say something. If you want, we can negotiate together about these subjects. Another application that both before presenter mentioned about connection of IoT and AI system. Okay, why we are telling about the connection of both of them? Because with the IoT system, we can create the infrastructures for receiving and transfer and initial processing. And with the application of artificial intelligence, we can execute appropriate logics in this parameter. For example, in all different processes that we have in the water and wastewater treatment plants, because in the recycling process in buildings, we should have one packages as the small wastewater treatment plants. For example, in some communities, such as European communities, we have gray water separately. We are gathering them in comparison of brown water. We are saying green water, gray water, and brown water. Each of them has a specific, criteria and a specific specification, and we need to use different controlling method. One controlling method that they are using in these systems are PID systems. It is, you can see the outputs of some PID system in, for example, a specific section of this infrastructure. For example, pump control system that you can see, because we should have some alarm management during this process. And with together, each of you, I will share these outcomes also with you guys, and we can have some email connection with together. Each person motivated by a specific target for EIL publication. We can negotiate with together, and we can complete these research items because they are completed at least for the standards of EIL and in TULTECH. Another issue that I want to talk about is related to one popular subject about the electrochemical techniques application for wastewater purification and controlling the system. But here, the main topic, some people, they are working in their research on the water quantity management. Yes, it is water resources, water resource management. And when we are talking about the quality of water, the complexity of each aspect of water management will be increased dramatically, because why I am telling you it is very important, because based on the type of contamination. We have lots of different mechanisms for diffusion, advection, dispersion, and if we have different hydraulic regime in the water, we will have different behavior. And okay, what is the connection between fate and transport of pollutions in different hydraulic regimes? And based on this fact, we should mention, for example, in electrochemical system, we have as well all parameters that I mentioned before. We have two electrodes in the system, cathodic one and anodic one, and we have one electric field between them, and complexity will be increased in this system. Okay, by the application of machine learning and meta-heuristic algorithm, we can increase the quality of controlling in this system. And you can see here, after this meeting, I will share with you some codes, a person who would like to work on it with us, about the publication that I mentioned. Also, some other colleagues, we will invite them from Europe for collaboration in this works, and then we can create one scientific report about this subject and the application of artificial intelligence and simulation approach for controlling the performance of this system. What is the performance? Pollution removal over the time, and why it is dynamic, because we have and also what is another criteria? Energy consumption. Why, if you come to the Middle East, there are lots of packages that you can find that they are working with this system because energy is cheap, specifically in Arab countries or Iran or Saudi Arabia, and they are using this system because energy is cheap. But if you are coming in Europe or Canada, USA, and other Western countries, just you can find electrochemical system for different application with integrated by renewable energy, just renewable energy. Without renewable energy, you cannot find them because it's not, beneficial for installers. Another aspect that I wanted to mention here was related to multi-objective of both of them, energy consumption and also removal of the pollution. It is another multifunctional parameter. Thank you for your consideration. If you have any question, I'm here for answering you.
Excuse me, sir.
Okay.
Sir, would you please go to the previous slide? Second
This
last.
one?
Yes.
Okay.
You have shown some graphs on the right side.
Yeah.
Concentration, efficiency, and energy consumption.
Yeah.
So what does it mean by the concentration? Is it is increasing with respect to time?
Yeah.
So the pollutant concentration over the time, it increases. Can you please explain it?
Yeah. Here, the concentration is concentration of byproducts. It's not the initial concentration. Initial concentration is decreasing, yes. But it is in this code that I will explain it if you're interested in this topic to you. It is related to byproducts because after the contamination, okay, the initial organic material concentration is decreasing. But what is increasing? The byproducts. Why we are simulating the byproducts? Concentration because of the toxicity. After, for example, about the PFAS, about different groups of PFAS, for example, PFOA or GenX. The most important issue after the contamination is connected to toxicity of byproducts. Why? Because PFAS is toxic material and completely it is canceric. But there are some shorter chain of PFAS that they are more canceric compounds, and because of that, we should simulate their behavior during the simulation for finding, okay, what is the initial toxic material that we have, and it should be decreased. Okay.
Yes, okay. And what about the cost effectiveness of these different techniques of like treating the water?
About the cost of what? Pardon?
Cost of treatment.
Yeah, it's very important. But here, we should decrease the some. It should be added. Yes, it should be added here because it is related to the topic of research. When you want to focus on the energy, on the performance, yes, but about the cost, it's very important, specifically in this method. But you should consider notice that in the electrochemical system in European countries, in Western countries, what is the main aspect of cost? Energy. Why we are evaluating energy more than, for example, material? Because you don't have any option for changing material. What is the material here? It is the electrolyte. We should add electrolyte for transferring the electrons between anode and cathode. Do you agree with me?
Yes.
Okay. During the process, we cannot change it because of operation. If you have, for example, if you have the metals here, you want to create some precipitation during this reactor by metal. For the operation system, you cannot change the electrolyte and the concentration of additive to the reactor because it should be constant. Even elsewhere in other scenario, you will have decreasing the pollution removal efficiency. But if you're interested in this subject, we can work together for creating a good research item for EIL, or maybe better condition as well EIL with a group of tool. We should consider some outputs such as Dr. Fatullah Ifar, Dr. Amir mentioned, if you remember, in his research item, they mentioned to pessimistic, optimistic, and moderate scenarios. We should find some criteria and solutions for our problem that meet all different aspects. How much you want to decrease the cost? If you are decreasing the cost 100%, you will have decreasing in the efficiency. You should present some multifunctional solutions to the principals. They should, maybe some principals in United Kingdom, they are finding one chromosome, for example, in genetic algorithm, they are selecting one chromosome. In the same problem in Qatar, maybe some other principles, they are selecting another chromosome based on the environment of the local condition about the pollution, because energy costs, material costs in your country, Pakistan, the material cost is very, very lower than other countries. Why? Because you are producer of some chemical materials in your standard. Some managers in Pakistan they want to select the one solution or one operational condition. Maybe they don't care to material costs because it's very cheap. But if they want to make decision in Canada, absolutely yes, they will consider the material costs.
Yes, sir, you are right. And there is a problem of choking of these filtration units. Like we have the cathode, so
about the filtration one, this one?
increasing. it will choke after some time. So the maintenance and these things of these membranes and these filters, it is also a factor of consideration, I think.
Yeah. Also about the I couldn't understand exactly your point about the problem here is about the you mean about the cost?
Yeah, about the cost and the maintenance of
Yeah,
this.
exactly. Because of that, I mentioned that falling process. What is the main part of maintenance here is falling. Because, for example, for saline water, if the falling process is increasing, the rejection rate will be reached to around more than I think 50%. You know, it's a very tough condition. We should solve it. And if we cannot, yes, maintenance is very nice target that we can consider, but we should break down the different aspects of maintenance. How we can compute maintenance during the process as the mathematical equations. If you evaluate the literature review and maybe now you have experiences, if you have experiences, correct my notice here. By falling process controlling and implement some smart model, for example, about the time of falling and type of detecting falling. You know, in the classical methods, they are finding it is the time of falling as we're changing between pressure, okay? With changing the pressure in the membranes and each sheet, they can understand, okay, it is the time of backwash, and after sending one order to PLC board, they are reversing the flu. But here, by controlling the falling, we can find better, understanding about maintenance. If you have any comment about showing the maintenance, inform me.
Yes, sir. In these ultrafiltration are just we have the rapid sand filters or slow sand filters that can be done by backwashing. But as far as these membranes are concerned, like the reverse osmosis membrane, so it should be completely replaced, and cost of that membrane is very high. So, like for commercial uses, they use RO filters, but for domestic purposes, it is very difficult to use these RO filters and such things.
You're right. But I should mention that, it is related to the type of pollution. For example, when you have saline water, you don't have any chance. Just you should RO, okay, reverse osmosis. Other methods, they are very expensive. But yes, when you have, for example, different types of organic material that they can trap to the porous media, such as TOC, total organic carbon reduction. In the rainwater, you can use microfiltration, or you can use in the microfiltration you can use rapid sand filtration, slow sand filtration. That is also I think in your country, in the rural communities, it is applicable. Because I know that I have some friends from Pakistan that they are working on this.
Yes, we do have, sir.
Yeah. They had one project in, I think, Faisalabad, one rural community there, and they use the slow sand filtration in rural community. But why they could use? Because the community population is very low. But if you want to use one system in mega cities, we cannot use, because we need lots of area. And very big area we need for implement this system. Therefore, we cannot use it, and we should use other methods, other applicable methods for this system. If it is connected to the condition that you have, pollution, flow rate, type of pollution, we should use it. Yes, I know. The reverse osmosis is expensive, operation is very complicated, but performance is very high. We have saline water. But for example, in some region in your country, in Punjab, you don't need to use RO system because you have lots of high quality water. But in the border of Iran, in Sistan, that you have also Sistan region, you should use the RO because you have lots of saline water and nitrate water. Water is polluted by nitrate. Just you can use it.
Yes, sir. Yes, sir. You are right. There, the TDS is very high.
Yeah.
So that's what we use.
Because of TDS, what should you? You don't have any chance. Just nanofiltration or reverse osmosing, and you know that the flow rate of reverse osmosing is more than other methods. And in big
Yes, and
communities,
our province in Khyber Pakhtunkhwa, we do have high saline water with TDS almost above than 1500.
Yeah.
So there are districts like Karak, Di Khan. We have this problem of salinity.
Yeah.
So we use there the RO filter.
Yeah. Exactly.
Okay, sir. Thank you. Thank you so much.
You're welcome. You're welcome. Okay. If everyone, if you don't have any notice about presentation, also we can finish the meeting and workshop here. And again, I should say very, very deep thanks to Dr. Amir and Professor Kurosh. Professor Kurosh, he's a full professor in University of West London, and honorably, I had some honor to collaborate with him from 4 years back, and also Dr. Amir is an expert and distinguished researcher in the application of meta-heuristic models in water and energy systems, and also it is my pleasure that I'm collaborating with him. Thank you so much again. Thank you. If anyone, if you don't have any question or comments, we can finish this meeting. And after workshop, we will be in touch with together for the following collaboration.
Just a comment. Thank you very much, Mohammed.
Thank you.
That's really a good and informative presentation. I really enjoyed.
Thank you.
So I hope the result of this workshop and presentations would lead to some further collaborations, as you just suggested at the beginning. First, it could be like any kind of like a research collaboration and resulting any kind of like a publication. So in the EIL journal as well, or any other journal, depends on the quantity and the quality of the work as well. So we are very positive and look forward for any kind of like the potential works with the team audience here. I hope they enjoyed, and we can carry on this and continue this collaboration further on.
Thank you so much. Also, I'm inviting all participators for collaborating further activities with us.
Yeah, exactly.
Thank you so much, Mohammed. It was very my pleasure that I collaborated with you in this workshop. I really enjoyed, and I also appreciate your time for both of you, Professor Kurosh and you, for their great presentation. I really enjoyed and learned new things. Thank you so much, and I hope we can collaborate more in the future.
Okay. Thank you so much, Dr. Ami, also from your side. And dear participators, if you agree, if you want to take a photo as the final this meeting, if you can open your cameras, if it is possible for you, we want to take a photo as the last part of this workshop.
I think you should have just informed me well in advance, Mohammed.
Yeah.
So everybody is prepared for that. Okay.
Okay.
So, thank you. Where is the...
Okay. Otherwise, yes. Maybe if you can... Okay.
Yeah.
Hi. Okay. Nice to meet you, Fayyaz. And nice to meet you, Mohammed.
Yeah.
Thank you.
You're welcome. Okay, one. Yeah. Yes, also if you can do. Okay. And also both of us. 1, 2, 3. Okay, thank you.
Thank you so much. Thank you.
Thank you very much. And so yeah, just Ruhullah, just switch on for a moment.
Okay.
So, maybe you can take another one.
Yeah. We should take another one because we are waiting you, Ruhullah, during this meeting. Sometimes we called you, but unfortunately we couldn't connect to you.
Yeah, go ahead, Muhammad.
Okay. 1, 2, 3. Okay, thank you so much.
Thank you. Thank you.
Thank you, everybody, and have a nice evening. Take care.
Thank
And
you.
have a nice weekend too as
Have
well.
a nice weekend.
Also to you.
Take care. Bye.
Bye.
Thank you. Bye-bye. Goodbye.